Good morning, OLC Middle School students. This is Mr. Woolley, and remember the information contained in this video is intended to be viewed only by the students in Mr. Woolley's classroom. By watching the video, you agree that you will not record or share the video with anyone who's not a student in Mr. Woolley's classroom. Alright, today we're talking about angle relationships in triangles. These are some examples we can talk about. We're going to start off today with an image kind of looks like this. And I have these two parallel lines that are moving up and down in the picture here. And it says when two parallel lines are intersected by a transversal, this transversal is a line that slices through them, they create a special set of angles consisting of alternate interior angles, alternate exterior angles, and corresponding angles. Now, what does this mean? Alternate interior angles are on the inside of the parallel lines. So you remember parallel lines have a little arrow on the top there indicating they're parallel. And inside of the parallel lines, those are our interior. Now, alternate interior angles would be 2 and 7. Those two angles are identical to each other. They're congruent. You can see it's an obtuse angle and an obtuse angle. 4 and 5 are also considered alternate interior angles. That's an acute angle. That's an acute angle. So 2 and 7 would be a pair of alternate interior angles. There's a second pair. 4 and 5 would be a pair of alternate interior angles as well. Now, the next one kind of makes sense. Alternate exterior angles, they're on the outside of the set of parallel lines. So on the outside here. And 1 and 8 would be considered alternate exterior angles because they're both the acute angle in the picture here. And 3 and 6 would be alternate exterior angles as well. That's another pair. And you can see those are both obtuse angles. So those are a pair. Now, corresponding angles, as we can see here. Corresponding angles are created because, since these two lines are parallel, this up and down vertical ones here, when that line slices through like this, it creates an exact replica. So this scenario right here repeats over here exactly the same. Now, corresponding angles mean they're in the exact same location. So like in this little image right here, this cluster, intersection of lines, angle 1 is in the upper left, angle 5 is upper left. They're corresponding. Angle 2 is upper right. Angle 6 is upper right. Those are corresponding. Angle 3 is lower left. Angle 7 is lower left. Those are corresponding. Angle 4 is lower right. Angle 8 is lower right. Those are corresponding. All right? So that means they're the same angle. Now, how does it apply to actually like using real measurements? Well, I can find the angle measurements if angle 3 equals 60 degrees. So look at our picture here in this image. My parallel lines are running from left to right. Angle 3 is right here. All right, angle 3 is 60 degrees. Now, I'm going to be asked to find angle 1. Angle 1 and angle 3 are vertical angles. If you remember from earlier this year, vertical angles are right across from each other instead of intersecting lines. So it forms a perfect X shape. 1 and 3, they're the same measurement. So angle 3 is 60, angle 1 is 60. Angle 2, I'm supposed to find angle 2. Well, angle 2 and angle 3 are right here together. We know angle 3 is 60. Well, they are in a straight line. Notice how this line's a straight line right here? Two angles in a straight line, if you remember, those are supplementary angles, and they add up to 180 degrees. So if I know that this is 60, I take 180 minus 60, and it tells me this missing angle is 120 degrees. This is from earlier this year, so that should have been one you recognize. Now, angle 7, I'm looking at angle 7. Now, keep in mind, all I know is that angle 3 is 60. So I come down here, angle 7 is a corresponding angle. This is going to be the same measurement, 60 degrees. This set of angles right here got repeated right down here as well. So angle 3 has a corresponding angle, angle 7, and they are the same angle. All right. Moving over to triangles now. Shifting gears a little bit from parallel lines and transversals. We have to find the value of x in each triangle. Now before we start, every triangle has 180 degrees if you add up all three of its interior angles. So all three of them, this x, this 45, and this mystery angle right here, you have to add up to 180. Now, I don't know anything about this mystery angle other than the fact that next to it is 130. But thanks to supplementary angles, this and this angle should add up to 180. So I take 180 minus 130, and it tells me that this angle is going to be 50 degrees. Now, since I know that this is 50, this is 45, and this is my x right now, all I need to know is two of them. Because I'm just going to add the two that I know. The 45 and the 50 add up to 95. And then If I take 180, because remember all the triangles have to add up to 180, 180 minus the 2 that I know, 95 degrees, is going to be 85 for my missing angle right here. So missing angle is 85. Remember, all three of them have to add up to 180. Once again, down in this example, x, 62, and a mystery angle have to add up to 180. Well, similar to the last problem, 110 and my mystery angle, those have to add up to 180 because they're supplementary angles from earlier this year. So I take 180 minus 110. It says that angle is going to be 70. So that little angle right there is 70 degrees. So all I got to do now is take 70 plus 62, add them together, and I get 132. And since all three of these have to add up to 180, I take 180 minus the 2 that I know, 132, and I get 48 for my missing angle. There we go. Next up, similar problem down here. The 165 on the outside is supplemental to this angle, so 180 minus 165 tells me this is 15. Then I add up the 2 that I know, 130 and the 15, and then I take them, the 145, I take them away from 180, and it tells me my final missing angle, which is going to be 35 degrees. All right. Now, of course, we couldn't not do some algebra types of problems with these. We're going to challenge you a little bit more. It says define the measures of all the angles in the triangle and then give the measure of the requested angle. Well, I know one of them is 110 right here, and then these two are x, so I don't know them. But all together, they have to add up to 180. So 2x's plus the 110 should equal 180. Well, solve like a two-step equation, minus the 110 from each side. I'm down to 2x equals 70. Divide each side by 2. X is 35, and that's really all I'm looking for, is just an x. So they're both 35. Now, 4x will be the one I'm looking for here. I'm going to have to do some extra. So in this picture, all these have to add up to 180. So 4x plus 6x is 10x, plus 2 more gives me 12x. So 12x is 180. Divided by 12, divided by 12, x is 15. However, there's not a single x in here all by itself. 2x would be 30, 4x would be 60, 6x would be 90. But in this case, I was looking for the 4x, so 4x is going to be 60. Now, in this case, I'm looking for x plus 2. I have an x plus 2, and a 64. So I just say, all right, I got 1, 2 of the x's. 2x's plus 64 and 2 makes 66. It gives me 180. So take away 66 from each side, and I get 2x equals 114 divided by 2. X is 57. However, I'm looking for x plus 2, so add 2, and I get 59 for my final answer there. All right, well, thanks for watching. Go ahead and give your homework a try in Schoology.